Hello everyone, and today I will be talking about the chunking strategies for RAG. So imagine this, there is same document, same LLM and the same question, but two completely different answers. One is perfect, other is garbage. The only thing that might have changed is how the document is being split. So that's called chunking. So if you have built a RAG system and the answer feels off, not wrong enough to be a hallucination, but not quite right either. So your chunking strategy is the problem. So in my last video, I have explained what RAG is, how it works. So today we are going to deep dive in the one step of that makes or breaks your entire pipeline, that is chunking. So I'm going to cover every major strategy, how each one works, when to use it, and when it will hurt you. So let's go. Uh, Before that, I will give a quick refresher for the RAG system. So in a RAG system, you take your document, break them into smaller pieces, turn those pieces into embeddings, and store them in a vector database. So when a user asks a question, you search the most relevant pieces and feed them to LLM. So that step of breaking documents into smaller pieces, that's chunking. And the way you break them changes everything. Words get retrieved, how much context the LLM sees, and whether your answer is accurate or not. Think of it like this. If you rip pages out of a book randomly, okay, so you will lose the meaning. But if you cut along the chapter boundaries, each piece still makes sense on its own. So that's the difference between a bad chunking and good chunking. Yeah. So let's go to the strategies, different types of chunking, right? Yeah. So the first strategy is fixed size chunking. Okay, this is the simplest strategy. You pick a number, okay, say 500 tokens, for example. Okay, and you just split the text every 500 tokens. No thinking, no structure, no just counting. So there are two types of this chunking. So one is character based, where you count the characters, and token based, where you count the token. So token based is generally better because it matches how LLM actually process the text. Yeah. So now here's the thing. If you cut exactly 500 tokens, you might cut right in the middle of an important sentence. So we need a overlap. So this means the end of one chunk and the beginning of the next chunk share some text. So usually 10 to 20% overlap works well. So for a 500 token chunk, you would overlap around 50 to 100 tokens. So let me discuss about the pros and cons for this. As you can see in this PPT, the pros are like it is dead simple to build, fast, very fast and predictable chunk sizes are there, and great baseline to start with. The only cons is ignores the meaning, can cut in the mid sentence or mid thought, no structure awareness. It is best for quick prototypes. Okay, testing if the RAG works for your use case, like if it is a homogeneous text like news articles. A recent benchmark by Flowtorch in 2026 actually found that the recursive character splitting at 512 tokens outperformed fancier methods in many cases. So don't sleep on this approach. Sometimes simple wins, according to Occam Razors. So the second strategy is sentence-based chunking. Yeah. So the sentence-based chunking, instead of counting the tokens, you split at sentence boundaries. Each chunk is one or more complete sentences. So you can use tools like NLTK or Spacey in Python to detect sentence boundaries properly. So they handle edge cases like abbreviation, decimal points, and titles that have periods in them. Okay, the main benefit of this is every chunk is at least a complete thought. You never cut a sentence in half. So the downside is that the sentence length vary a lot, so your chunk won't be uniform. Some might be 50 tokens, some might be over 500 tokens. You never know. So let's get into the pros and cons for that. Okay, there are no broken sentence, preserves the basic meaning, easy to implement with the NLP libraries. But the downside is It has uneven chunk size. Single sentence may lack the context. Doesn't respect the document structure also. So it is best for mostly FAQs, short form content, conversational data, chat logs, etc. So next comes recursive chunking. Yeah. So this is one of the most popular that people should start with. It is default in the langchain for a reason. Okay, so recursive chunking works top down. So you give it a list of separators in order of priority. It tries to first separate like double new lines, which usually means paragraph breaks. If a chunk is still too big, it fallbacks to the next separator, that is single new lines. Then the periods, then spaces, it keeps on splitting until every chunk fits your size limit. Okay. So the beauty of this is that it respects the natural structure of the text. Paragraphs stay together when possible. Sentences stay together when paragraphs are too long. It's smart approach in this process. So here's the pro tip. If your document have clear section markers like heading in a manual or a label like descriptions, side effects in medical books, etc. Or add those as a custom separators at the top of the priority list. In that way, entire section stays intact. So for this, the pros and cons are like this it has structural awareness, consistent sizes, customizable separators. Okay, 80 to 89% recall in the benchmarks. But the cons are that it needs separator tuning per doc type, doesn't understand meaning, just structure. It is best for 80% of the RAG apps, general purpose documents, markdowns, HTML code files also. Yeah. So the next is document or structure based chunking. The fourth one. So this strategy uses the built-in structure of your document to decide whether the chunk, if you have a markdown file, okay, you split by the header. If it is HTML, you split by the tags. If it is a PDF, you split by the sections or pages. So the idea is simple. The person who wrote the document already organized it logically. A heading followed by its content is a natural, meaningful unit. So let the document structure do the work for you. Let me tell you a fun fact. So NVIDIA's 2024 benchmark found that the page level chunking actually achieved the highest accuracy in their test. So for well-structured document, this approach can be surprisingly effective. So the pros for this is like it is preserves the logical organization. Okay, chunk makes sense on their own. No ML model needed. And the cons is that it assumes good structure. Okay, chunk vary wildly in size, doesn't work for unstructured text. Okay, it is best for technical documents, wikis, markdown HTML, legal contracts with the clear sections. Okay, so let's move to the next chunking method, the fifth one, which is semantic chunking. Now we are getting into advanced stuff. Okay, so semantic chunking is where the chunk actually understands the meaning. So here's how it works. You start by splitting text into sentences. Then you create embeddings for each sentence. Then you compare the similarity between the neighboring sentence using the cosine similarity. When the similarity drops significantly, meaning the topic is shifting, you create a new chunk boundary. So instead of cutting based on size or structure, you are cutting based on meaning. When the text shift from the talking about pricing to talking about features, that's where the split happens. Yeah. As you can see here in the graph also. So what's the catch? So the catch is you need to pick a similarity threshold, and that threshold varies between the documents. If you set it too high and you get tiny chunks. If you set it too low, you get a huge chunks that mixed topic, that has the mixed topics. So you will need to experiment with that. Also, this method requires running an embedding model on every sentence during the ingestion. So that's slower and more expensive than the similar methods. But the retrieval quality can be significantly better, especially for the dense technical content. So coming to the pros and cons, the chunks are topically coherent, better retrieval precision is there, and adapts to the content naturally. The cons is that it is computationally expensive, threshold tuning needed, and slower ingestions there. It is best for kind of research papers, dense technical docs, content where the topic shifts without clear headings. Okay. So let's go to the next one, which is contextual. Just a second. Yeah. So this is the sliding window chunking. Let's go to sliding window chunking. Yeah. The sliding window is like fixed chunking. Fixed chunking's smarter cousin, you can say. Instead of cutting and moving forward, you cut and slide. Okay, so each new chunk starts partway through the previous one. So if your window is 500 tokens and your step is 250 tokens, so chunk 1 covers the token 1 to 500, chunk 2 covers 251 to 750, chunk 3 covers 501 to 1000, and so on. So every piece of text appears in two at least two of them. Yeah, two chunks. And why do we use this? Because no matter where an important sentence falls, it guarantees to be in the middle of at least one chunk, surrounded by the full context of both sides. This is a huge for retrieval quality. So the pros are like it has a great context coverage, reduces the boundaries problem, up to 14.5% recall improvement is there. And but the problem with this is double or triple the storage. Okay, more embeddings to compute, and even it can retrieve duplicates also sometimes. So it is best for long narrative, like maybe legal document. It can be used. Any text where context at the boundaries is critical. It should be used. Yeah. So in case of let's go to the next strategy, that is hierarchical chunking. Hierarchical chunking is a really clever approach. Instead of one layer of chunks, you create multiple layers like a tree. At the top level, you might have a summary of the entire document. Below that, you have a section summaries. And at the bottom, you have the detailed chunks. So when a user asks a question, you can first search the summaries to find the right section, then search within that section for a specific detail. Think of it like a book. So the table of content helps you find the right chapter. The chapter heading helps you find the right section. And then you read the specific paragraph. So this is the hierarchical chunking, gives you like the RAG systems the same ability to zoom in. So the pros of it is like it has multi-level retrieval, it is flexible, so precision is there, even great for large document collections. But the cons is it is complex to implement, need a summary generation and more storage and indexing also. It is best for like large knowledge bases like enterprise doc search and multi-topic manuals and textbooks. Yeah. So next, let's move towards, yeah, contextual chunking. Yes. So this is the eighth strategy, contextual chunking. This one is popularized by the Anthropic in 2024, and it's really elegant idea. So here's the problem. When you chunk a document, each chunk loses context about the overall document. So if a chunk says its population is 3.85 million, the chunk alone doesn't tell you what has 3.85 million people. The it's referred to Berlin, okay, which was mentioned in the three paragraphs earlier. So the context is gone. So in contextual chunking, it fixes this. So after you split the document, you use an LLM to generate a short context summary for each chunk. Sometimes like this chunk is about a population of the Berlin, Germany. So that summary gets pre-penned to the chunk before embedding. So now the embedding captures both the detail and the broader context. Research show that this gives a 2 to 18% improvement in retrieval accuracy, is one of the highest impact, lowest effort upgrades you can make to an existing RAG system. So this preserves document level context, easy to add on top of any chunking method. So it has a proven results also. So the cons is it requires LLM calls during ingestion, adds the cost and latency. The context quality depends on the LLM that we use. So it is best for mostly documents with lot of pronouns and references, etc. And upgrading existing RAG system, it can be used. Any pipeline where retrieval accuracy needs a boost, this method can be used. So coming to the next chunking method, which is the ninth chunking method, is late chunking. Okay, so the late chunking flips the traditional approach of on its head. Instead of chunk first, embed later, you will embed first, then chunk later. So here's how it works. So you take the entire document and feed it in to a long context embedding model. So the model produces the token level embeddings for the whole document because it sees the full text. Every token's embedding is influenced by the entire document context. So then you split the token embedding into the chunks and average them. So what do you think would be the result? So the result is each chunk's embedding captures the full document context, not just its own isolated text. So when a chunk says its population, so the embedding already knows that it refers to Berlin because the model saw the full document before chunking happened. Even Jina AI pioneered this technique and it shows around 10 to 12% improvement on queries involving pronouns and differences. So it's computationally efficient compared to contextual chunking because you don't need extra LLM calls, but you do need a long context embedding model. So let's come to the pros and cons for this. So the pro is the full document context is in every chunk is being provided. No extra LLM calls needed. No added text to store. But the cons is need long context embedding model, can sacrifice some relevance, and even newer techniques are there. Okay, less battle tested. It is best for narrative heavy document, content with lots of pronouns and cross references. So cost sensitive pipelines, we can use this. Okay, let's go to the next chunking method. This is the nuclear option. Yeah, agentic chunking. Okay, this is the last strategy that we're discussing about. So agentic chunking. So now the most advanced strategy is agentic chunking. This is where you let an AI agent decide how to chunk each document. The agent looks at the whole document, its structure, its content type, its density. Then it dynamically picks the best chunking strategy for each section. Maybe it uses semantic chunking for the narrative parts, preserves the table as single chunks, split code blocks differently, and keep the list together. So think of it like a human editor who reads all the document and decides the best way to organize it for the search. Except it's an LLM doing it automatically. So the results can be excellent, but the cost is real. You're making multiple LLM calls per document. For a 100-page manual that adds up fast, this is for high stake applications where retrieval quality matters more than cost. Think like legal, medical, or compliance. So the pro is it adapts to any document type, best possible chunk quality, handles mixed content very well. But the cons is it is most expensive, slowest ingestion, complex to build and maintain, and it is non-deterministic. It is best for only legal, medical compliances doc. Mixed format documents are there, then it is okay. And high stake applications where accuracy is everything. For those, we use this. Yeah. So let's do a complete comparison here. Just a second. Yeah. So, all right, let me put it all together in one view so you can compare everything side by side. Yeah. So as you can see, the fixed sentence, it has a low complexity, it's free, quality is low. Best use case is for prototyping. Recursive is for medium complexity. The cost is free, the quality is medium to high. It is a sweet spot default. Next comes semantic. Complexity is high, cost is also medium. Quality is high, but the best use case is for dense or shifting topics. Next comes the contextual or late contextual. So the complexity is high, cost is medium to low, but quality is very high, and accuracy boosts can be given using this. Next comes the agentic. So the complexity is very high, cost is also high, quality is maximum. It is good for legal or medical. Yeah. So, so let me explain you how to pick the right strategy. Okay. All right. So we have got 10 strategies. How do you actually decide which one is one to use? So let me give you a practical decision framework. Question one. Are you just testing if RAG works? So use the fixed size as 512 token with 50 tokens overlap. Done. Don't overthink. If you're just testing if RAG works. If do your documents have clear structure like heading, sections, or markdown? Okay. Then use structured based or recursive chunking. Let the document tell you where to split. Okay. So the next question you need to ask is your content dense and topic shifts without clear markers. So go semantic chunking. It will find the topic boundaries for you. If are your answer good but not great, if you feel this question, so then add the contextual chunking on top of whatever you're already using. Okay, it is the easiest upgrade with biggest impact. Okay, so next question that you need to ask is, are you dealing with legal, medical, or compliance documents where accuracy is everything? Then consider agentic chunking. The cost is worth it when mistakes are expensive. And here's is the most important advice. Always measure. Use metrics like recall, precision, and faithfulness. The Ragas framework I mentioned in my RAG video is perfect for this. Don't guess which strategy is best. Test it. Start simple, measure, then upgrade. Don't start with the fanciest strategy. Also, one thing that surprises most of the people is metadata matters as much as chunking strategy itself, because the adding the document title, section heading, date, and source to each chunk lets you filter results before the vector search even happens. So the single improvement that can outperform switching to a more complex chunking method is adding this metadata. Okay. So we can filter the using the metadata, and frameworks like Ragas. Langsmith can also be used to get all this recall, precision, faithfulness, etc. So let's wrap up. So chunking is the most underrated step in any RAG pipeline. Everyone is obsessed over which LLM to use, but the quality of your answer is determined by what you retrieve. And what you retrieve is determined by how you chunk. So today we covered 10 strategies from the simple fixed size and sentence based to advanced like a semantic, contextual, late contextual, agentic, chunking, etc. Each has its place. So my recommendation is start with recursive chunking, add metadata, measure your results, then upgrade with a semantic or a contextual chunking only when the simpler approach hits a wall. Don't engineer beyond what your use case is. Okay, whatever your use case needs, don't over engineer. Yeah. So if you haven't watched my RAG explainer video yet, go watch that first. I will link it right here. And if you want me to do a hands-on coding tutorial where we actually build a RAG pipeline and test different chunking strategies, drop a comment below, like, subscribe, and I will see you in the next one.